Hello, everyone, and welcome, and thank you for attending this session today. My name is Derek Martin. I manage our solution architect team at Blackbaud, and I am going to step off the stage and let this team introduce themselves and get going with their content.
Thank you. Hello, everyone. Welcome here today for our conversation around OAuth 101. I'm Lucas Westervelt. I'm the team lead of the group responsible for supporting the SKY API ecosystem. Leading along on this journey today will be Chris Rodgers, the lead engineer of our team, and Michael Timms, another fellow engineer on the team. You might recognize these folks. I think these are some familiar faces from the Sky developer community. The inspiration behind this talk actually came from the feedback from the community. We've heard some things through the mailbox, through the developer portal, meetings in persons, all things like that. And we wanted to dive into some of the background behind OAuth and some of the decision-making process that went into it. Excuse me. We hope that providing some of the historical context on the decision-making process will help clarify some questions that have arisen. After that, we want to dive into some of the best practices to help solve some of the decision-making process that you've gone into when you're doing your development practices of your app. And then we'd like to wrap up by diving into some common challenges that we've seen, and we hope to provide some solutions to those. We have some time for Q&A at the end. If we are unable to get to your questions, though, we have an Ask a Sky API developer session scheduled for tomorrow at 10:30 a.m. So we'll make sure to get those questions sent along to there. So I will start things off. So let's all hop in a time machine. We're going to go back to 2006. Not to date myself, but this is the year I graduated high school. The number one song was Bad Day, if you're familiar with that. Unfortunately, it will not play. Blackbaud did not have the budget for it, but hopefully it's not a reflection of the great day we've all been having here at BB Dev Days. At this point in time, the modern web of interconnectivity didn't exist yet. Organizations were just starting to realize that one application might want to connect to another. And this new dilemma came up, which is how could they connect these applications and provide the data integration required to power this modern connected world without sacrificing security. Up until that point, frequently users would just send their username and password to a third party and hope that along that chain of custody, that best practices were followed and those credentials were never exposed. This obviously is not a scalable solution and not a secure solution. Things were very different back then in a very cybersecurity conscious world. I think many of us would not think that that'd be a good solution, but at the time it was the best that they had. Luckily for us, this group came together and they wanted to establish a standard protocol for across the industry that was easy to use and secure. This organization, this group came together and came up with OAuth 2.0. This framework that we've now started using at Blackbaud, it was published in 2012, but like I said, it came from 2006 originally. So as you can see, this is an ever-evolving framework. OAuth 2.1 is actually on the horizon as well. Some organizations have gone as far with OAuth to actually adopt it for all internal communications as well, with Google being one of the organizations that lead the way. From my understanding at Google, if there is an authentication request made, it's going through that same authentication service. So let's double click on that problem that we're trying to solve here and how that solution of this idea of delegated authorization comes from. An organization, so Blackbaud in this case, it has a resource server, SKY API, that has access to a user's data. As Blackbaud, we'd like to expose this service and expose this data to third parties and to our clients for their use. One of the issues that we have, though, is we don't expose his username and password. We don't expose his credentials. So we need to come up with a solution to this. That's where this authorization server comes in. This authorization server, or OAuth server, acts as an intermediary between the third party and the resource server to ensure that the credentials are exchanged and a token is generated so that those credentials never leave the organization's ecosystem itself, which would introduce a security risk. I know there have been a few alternatives in the space that people have discussed. The HTTP basic authentication that we kind of touched on here earlier, that previous method, these all had a few different trade-offs, but overall, the drawbacks of each helped to drive the decision for Blackbaud to go with OAuth. Touching on some of the strengths that OAuth offers, I kind of want to highlight these. I know there's been some feedback that OAuth is complex, but within its space, it's actually a simpler and easier framework to use. There's different ways that people have tried to solve this problem, but OAuth has been found to be one that's, like I said, it's an industry standard. So there are lots of resources available. There are client libraries that you can leverage. if a developer is getting involved in a space that is not nonprofit related, they're probably going to run into OAuth. OAuth is a very frequent protocol. It is an industry standard for API authorization. Its use of tokens helps to enforce best practices. That's part of all this that makes this kind of this industry standard tool. So as I'm wrapping things up, I'm going to hand this off to Chris Rodgers. He's going to dive into some of these best practices. We hope will help simplify things further for you. Chris, off to you.
Sure. Thank you, Lucas. To start off with best practices, I'm going to start off by talking about the next slide, which is our public versus confidential clients. When we're talking about clients, a lot of times we use that interchangeably with applications. If we're talking about your OAuth client credentials, we might also say application credentials. They're interchangeable. If you ever hear those terminologies, that's the same thing. For public clients, these are applications that are standalone and kind of run within the context of a user's machine. So for single page application, that would be an application that's running within the user's browser, or a standalone native application that would be making calls out the Sky API. And because these are running exclusively within that user environment, you can't secure your application secret. So by definition, public client can't secure their application secret. And because you can't use your application secret, you can't have refresh tokens, which means after 60 seconds or 60 minutes, your access token will expire, and you must reauthorize. The user must reauthorize to get a new access token, which would work depending on your application's architecture and your user case. For confidential clients, these are applications that can secure that application secret. These are generally applications that have a secure web server backend. So these are web apps or some other light client that has a server backend where that server is really the thing that's securing that application secret. And because the application secret is used in that case, you can obtain a refresh token for long-lived Sky API access. Refresh tokens are good for 365 days. And every time you exchange one, you get a new one that's also good for 365 days. So theoretically, if you're doing this on a regular basis, you should have connectivity forever, in theory. Because you are using your application secret, this is the one case where you kind of like a unique best practice here about rotating client credentials. You can, when you manage your application, go and you'll have two sets of application secrets. You can rotate between them depending on your organization's sort of best practices and policies for that. But for most part, for public and confidential, a lot of the practices are the same. So when you actually initiate the OAuth flow, the use of state and PXE is a good practice. If you're doing, so PXE there, PKCE, proof key for code exchange, that's required for public clients. PXE is required for public clients. It is basically your way of validating and proving that when you exchange an authorization code, that you are the application that initiated that user authorization. This is just your way that if somebody got your authorization code in flight, they couldn't exchange it on your behalf. Only your application can do that. State is more for your application to kind of prove to itself with any context that you need for that application. So when that user authorizes your application, you get that state parameter back, and then you can validate or correlate anything with any user application context or user context that your application just needs to function appropriately. For development versus production apps, that bullet point there is really about the user side, like how your team is going to manage your applications and kind of separating your public or your production applications from your development applications. You kind of want the least privilege access here, only having users who should have access to your application have access. And then if they do have access, they are limited to whatever roles that they serve. So if you have a marketing person at your organization, that you're not inviting them as a developer application role, which would have access to your client secrets. So this is just like limiting the exposure for that client secrets for those credentials. And then that last bullet point about redirect URIs, that's just about limiting and removing test and development redirect URIs from your production applications. Unfortunately, we do see this from time to time. This is just good for two reasons. One is that you aren't unintentionally sending an authorization code to a test URL in your application. That's probably just an unintended application behavior. The second reason is that if that endpoint can exchange that auth code, that probably means that your application credentials are being put in places that it shouldn't be. only your production instances should be able to exchange those credentials. Those last bullet points will go in there for securing credentials. This is you're good. You're good, Lucas. So securing credentials. OAuth this is kind of just general application best security practices, but for OAuth, OAuth by definition already sort of mandates some of these. Exchanging credentials over HTTPS, that's kind of one of the mandates of OAuth. The other part there is because OAuth requires sort of a two-factor, in a way, credential exchange. You have your application secret and either an auth code or a refresh token. There's always two credentials that are being exchanged to get access to a customer environment. You're not just having a basic auth credential that, well, that's the user credentials, but also you can't just leak that one credential and potentially expose customer data. The different boxes here, storing is really about limiting access to that storage account and then encrypting it there. So if somebody were to get access, they wouldn't be able to do anything with it. The last point there about local and session storage within the browser, that's more for, I guess, a public application like a SPA, where you get an access token and you're trying to sort of maintain state in session as the user is using it. Just knowing that if you're in a environment where that user might be on a shared machine, putting anything into browser storage, especially an access token, might be a bad idea. So maybe you want to limit the use of that. Transfer, like I said, OAuth already mandates the use of HTTPS, so that's kind of covered there. We've been doing our part on our side. If you noticed any of our community announcements in the last few years about limiting the number of cipher suites that we support to reduce the use of some of the weaker ones that have been sort of deprecated in the industry over time. And then the use of TLS 1.3, if you're able to do so. We support TLS 1.2 and 1.3 now. And then you have public clients there. That's just, you shouldn't be exposing any sensitive information within your application. That's the reason why you can't secure your application secret. For rotation, this is mostly for confidential clients. But yeah, the ability to rotate your application secret does exist. And if your organization has a practice around that, you can kind of add that application secret to that list of credentials that you have to rotate on a regular basis. The last bullet point there about preserve refresh token. Preserve refresh token is a way for your application to use a refresh token more than once. Generally speaking, an application wouldn't have to do that based on how it's architected. But if you do have to use it, then just keep in mind that because you're exchanging that refresh token more than once, you might want to consider before that 365-day mark rotating it, which just means exchanging the refresh token as any other application would. Next slide. And this login and alerting slide, this is really about your application, how you can take steps to troubleshoot whenever you have OAuth issues. And if you do have to reach out to us through support, that you have information to do so. The when to log is really, it kind of follows the OAuth flow. So user authorization temps, this is when you're sending somebody to the consent form, or when a user authorizes your app, or potentially if it fails, if there's an error in doing that consent. The access token restraint exchanges, these are for auth code and refresh token exchanges. So any errors that you have there. Just logging this might be also good in general, not just for failures, but if you're seeing that you're doing a lot of OAuth exchanges, that might indicate an issue with your application. It's just based on how you've architected it. It might indicate that you're sending a user through the authorization flows more often than you would expect. So that might be good information to have. And then when you have any failures, so if you're getting a consent denied from the user, or it might indicate an application config issue where maybe no users can authorize your application because there's an issue with how you've configured your application. Then what to log. I wanted to put that math sensitive values bullet point there first. You shouldn't be putting any insensitive information to plain text, and that definitely includes refresh tokens, and to a lesser extent authorization codes, even though those are short-lived. Masking in this case is just if you do need to log it, that you're only logging like the first 5 characters or first and last 3. Those are just examples, but you don't want to put just the full refresh token into plain text. As helpful as it is to have it, you don't want to expose that where it shouldn't be exposed. Application context is really about your application, just having whatever context, and this is going to be completely based on how your application is designed, but whatever context that you need to be able to troubleshoot an issue. I have state and code verifier there. If you're using Pixie, if those are sensitive to you, then you probably want to mask those as well. User and customer context, that's really about the Blackbaud user and customer. If a particular customer of yours and ours is having issues, you probably want to reach out to them and proactively help them through an issue if they are experiencing problems with your application. The OAuth error bodies, occasionally we get in the community messages about having certain errors and not having enough context. A lot of our messages do have some context, like if you get an invalid client error, that will usually say something about either the application ID is invalid or the client secret is not valid. That might be good information for you to troubleshoot. And then when to alert and notify. This is really when you need to take action with your applications. For user authorization, and this goes to just application configuration issues in general. If the error is indicating that you probably have a code problem or an issue with the way that you configured an application. So if you're getting like unsupported response type, invalid request for user authorization, or if you're getting invalid client, invalid redirect URI, or unsupported grant types, those are probably errors that aren't just one-off. Those are probably issues in your code that it's probably going to fail every attempt to do OAuth. You probably want to immediately address those. And then this last bullet point is about after some number of failed authorization attempts, your application is going to have to expect some level of auth failures for expired tokens, or a customer has disconnected your app, or those kind of things where your application or your refresh tokens are no longer valid. Some level of invalid client errors are probably to be expected, but a large number of them, either for a customer or in general, might indicate an issue with your application. And to talk more about common issues, I'm going to hand it off to Michael.
All right. Thank you, Chris. So hey, everyone, now we're going to shift over. We're going to talk a little bit about some of the common challenges when getting started with Sky API OAuth authorization. First, we have a very important topic, an integral part of your application. At the beginning stages of app development, you'll want to design the approach in which you'll manage authorization tokens for your users of your apps. Some of the items to understand are: one, access tokens expire in 60 minutes. Refresh tokens are used to generate a new access token, but they're a one-time use only, just single use, and then the refresh token's burned. When designing your application, how will you handle the possibility of different requests triggering a token refresh simultaneously? From day one, build token error handling, as Chris just touched on earlier. Sky API documentation includes an extensive list of common authorization errors, which we'll provide a link to later. Build logic to handle invalid grant errors. It usually indicates a new token needs to be generated. If tokens continue to fail generation, it could mean that the Sky application's been disconnected from the customer's environment. So when this happens, it's good practice to have your app fall back to reauthorization. So it'll prompt the user for consent, and you can also invoke it for a particular environment. A few of the specific items to mention as they're related to managing tokens: refresh token request synchronization. There could be several ways to prevent timing issues with simultaneous refresh token requests, but just make sure you're synchronizing your refresh token attempts in your particular programming language or framework. For example, some languages have the ability to synchronize calls by using a thread-safe singleton instance, and that can manage your refresh token requests. There's refresh token conflict resolution. So what is this? It's when read and writing your refresh token to storage, ensure that your refresh token that is currently in use is what's being updated in storage after you make a successful attempt or an error attempt to refresh a token. If there's a newer version in storage, when you go to update it, you want to just make sure that you're resolving to the newest version of that token. OAuth libraries, so there's many languages and frameworks out there that have OAuth libraries, extensions, and they're available for use. Blackbaud's OAuth implementation adheres to the OAuth 2.0 spec, and it should be compatible with a range of third-party libraries of your picking. And then, as mentioned before, provide a fallback to reauthorize your app, and provide a logout experience that clears the token storage and the cache for the user. So now we're going to move on to server to server OAuth flows. So this is a particular flow for applications that sync data between Blackbaud and then their own custom data source, very popular. These are usually not limited to scheduled jobs that query Blackbaud SKY APIs, and they pull data down at regular intervals, say nightly. So most of these are headless apps. They don't have a user interface. However, this can present a challenge because a user of the app still must give consent to access Blackbaud data. After that initial authorization, though, and you acquire a refresh token, now the app has what it needs, the refresh token, to continue to get access tokens every 60 minutes. And that doesn't require any user interaction with a consent form to go out and refresh the token. But even these types of headless apps, they need some way of reauthorizing. In some cases, like we mentioned before, becoming out of sync. This means there still must be some way of reauthorizing the app for acquiring a new refresh token. So you'll need to design what that initial and that reauthorization experience looks like for your situation. Sometimes for in-house, enterprise type apps, using a third-party tool like Postman for the authorization experience is okay, and it can give you that initial refresh token that you can provide to your headless app on the command line or however you want to do that. In other cases, if you have a consumer-facing app, these types of apps should have some sort of custom-built authorization experience that can present the authorization form to the user. And the final challenge as it relates to Sky application scopes. So this is a fairly new security measure that's been put in place to enable developers to define the appropriate scopes their application requires when accessing data on behalf of an authenticated user. So your application can be given either full access, limited access, or no access to Blackbaud data. The recommendation moving forward is the limited data access, but it does come with the responsibility of handling missing or outdated scopes for the authorized user. The Sky API OAuth 2.0 server will return the current set of approved scopes in the token response. So refreshing a token is going to return to you the most up-to-date scope access for that user in that environment. Your application can inspect that list of scopes to determine whether the user has approved any recent changes you've made to your application scope. So be aware that mismatch in scope access could also be related to the customer's environment missing a scope due to their environment's capabilities. For example, if their environment doesn't include a particular Blackbaud product like Razor's Edge NXT, then those particular scopes that maybe your app might support, they're still not going to come back in the token response. So just be aware of that. And more information about different Sky application scope values that can be found in the token response, they can be found in our documentation. We have some pretty good documentation out there. Feel free to head out there and read it, and I will pass it back to you, Lucas.
Thank you, Michael. Appreciate it. Yeah, and those aforementioned links are right here. The team is always working to keep our documentation up to date, but with the development of this presentation, we put a little extra shine to our OAuth doc. So if you get a chance, please take a look. We have some new pages out there, some updates. I also wanted to call out, as Michael mentioned, this idea of using a client library. If you go to the official, Blackbaud does not endorse a client, but if you go to the official OAuth website, there are some great options there you can use. And as always, just plugging some of the REST clients. I know there's been some communication in the chat about people who've used Postman in the past for this. So that's always a great tool. Insomnia and Arc are as well. So I believe that is it for the prepared portion. I know we only have about 6 minutes left. We'll go into the Q&A, and anything we don't get to, we can hand off to the Q&A session tomorrow. So I'll open it up. Yep, I will share those slides, and I will make sure to share all those links out as well.
Question in the chat, Lucas, from Susan. And she asked, does Sky API require OAuth?
Chris, I can answer this one, or you maybe get more in depth. But yes, it does. And Chris, if you want to add any more flavor to that, or yeah, just thumbs up.
No, I think you got it.
Sometimes the best answer is the simplest one. Yes.
Yeah, and part of that is the benefit of Sky API, I think that you'll see is that it's a unified approach across the APIs. So like the infrastructure itself is the same. So you authenticate the way you do for every product, mostly using OAuth. So I think that's part of it, providing a standardized surface for us. I saw something about the recording. Yeah, we do have I believe these are all recorded.
Manuel asks how long an access token lasts.
That is 60 minutes.
Okay. Tom wants to know if there's a link to a Sky API Postman collection.
So this is for a particular API. You can go to any of our endpoint reference pages and download the Open API doc. If you pull that into Postman, it will build out a collection for you. So if you go to like constituent API, and if you're at the top, there'll be a dropdown for the spec. You can download Open API 3, for example, and plug that into Postman. It'll build you a collection.
Great. Susan again asks, any advice on security questions I should ask a vendor that is using Sky API?
Yes, if you look at the marketplace applications that we have, there's a security attestation page where many of our application vendors have provided some answer or questions. If an application hasn't answered those, or if it's an application that isn't officially listed in the marketplace, if you're just working, say, with a consultant, those would probably be good questions to ask them. I would probably refer to that list, though.
Manuel has a follow-up on how long access tokens last. The answer is 60 minutes. So I think I heard this. I'm not a pro coder myself, but Manuel asks, after 60 minutes, you have to log back in and reauthorize.
So if you have a confidential client where you're exchanging your client's secrets, you get both an access token and a refresh token. That refresh token is good for 365 days. As long as you exchange it within that 365 days, you'll get a new combination of access token and refresh token. That refresh token is also good for 365 days. So theoretically, you should be able to keep doing that forever. And that doesn't require user authorization. That's just your server-side component. Now, if you have a public client where you don't have a server-side component, where it's a public client, like I talked about, yes, you would have to have that user reauthorized each time.
All right, looks like the questions have dried up. Great job, you guys. Really informative. I'm going to open the survey and ask all of our attendees to please take a few seconds to rate this content. And thank you again for attending. I hope everyone has a great conference, and thanks to our presenters here.
Thank you.
Thanks, everyone.